Hello everyone, welcome to Factoring and Simplifying Rational Expressions. Our learning target today is I can factor polynomials and I can simplify rational expressions by removing common polynomial factors. If you want a copy of these notes, they are in Schoology, so you can pause the video at this time and you can find those notes in our distant learning folder. Let's start by looking at different ways to factor polynomials. First, we are going to factor using the GCF. There are two terms in this polynomial. That's usually a good indication that we'll use a GCF. First thing you're going to look for is if there is a common number between the two terms in your polynomial. And here we have a 3 and a 27, so they both have a 3 in common. Secondly, we are looking at the variables to see if they have any variable in common, and they each have an x in common. So your GCF then is 3x. And then dividing your GCF out, your 3's will cancel. One of your x's will cancel, so you're left with an x. 27 divided by 3 is 9. And your x's will cancel out as well, so you're left with 3x times x plus 9. When factoring a basic trinomial, first, since it's a trinomial, it will factor into two binomials. So we'll get our brackets ready. And when we have a basic, we are just trying to figure out how we can multiply to a negative 16, which is our last term, and then add to our middle term, which is negative 6. And if you know your multiplication facts and start trying those, you could multiply negative 8 times 2. That'll give you negative 16, and then those will also add to negative 6. So we have x minus 8, x plus 2. Thirdly, when we have an advanced trinomial, you'll notice that there is a leading term in front of your x squared, which make things a little bit more difficult, but we'll be all right. But again, it's a trinomial, so we're going to go make our brackets. And to get to 3x squared, my first terms of my two binomials are going to have to be 3x and x. My last term is negative 10. So thinking how FOIL works, I have to have my second terms of my binomials multiply to negative 10. So something like positive 2 and negative 5. So my first terms, I have 3x and 1x. Now a quick way to check to see if your factors are lined up is you can check your outsides, which would be 3 and negative 5, which makes negative 15, and then 1 and 2, which makes positive 2, which adds up to negative 13. Now that number should match your middle term of your polynomial, which in this case it does, which now shows us that our polynomial factors are 3x plus 2, those top two numbers, and then x minus 5, those bottom two numbers. So we'll fill that in. (3x plus 2, x minus 5). Lastly, we have a difference of squares. So a difference of squares will always have two terms, and it'll always have a subtraction. And then the one big thing that you'll notice is that you'll always have a perfect square. Perfect squares are numbers that you can square root to a whole number. Perfect squares will also factor into two binomials, so we'll have our two parentheses. And they factor into two conjugates, so we'll have a x plus and an x minus. And all we need to do now is take the square root of 25, which is 5, x plus 5, x minus 5. Our second learning target is to start to simplify rational expressions. The skills we practiced above, we'll practice in example 3 here in a second, but first we're going to look at simplifying monomial rational expressions. So here we're just simplifying, looking for common factors between our numerator and denominator. And since we do have variables in the denominator, we are also going to find excluded values. So just recall that excluded values are values for the variable that make the denominator equal to 0. And since we cannot divide by 0, that would be a number that would not work in our expression. And remember, you can always pause the video if you need to slow down and write things down. So if you need to write that down, you can pause right now. The excluded value will make the denominator equal to 0. So we'll take our denominator, 10y to the 4th, and find out what makes that 0. So it cannot equal 0. Well, since this is all being multiplied, y to the 4th, simply y cannot equal to 0. Now we look at simplifying. So it is a fraction. So I'd like to start with the numbers. Look at, you got a 5 and a 10. They both have a 5 in common. That becomes a 1 and a 2. X squared in the numerator. No x squareds down in, or no x's down in the denominator. Y to the 7th over y to the 4th. We'll use our division of powers rule, which will subtract our exponents. So these 4 y's will cancel. 7 minus 4. We're left with 3 y's up in the numerator. So now we're simplifying to 1 x squared y to the 3rd all over 2. And that'll be our final simplified answer. Our second problem, we have a 3a to the 5th, b to the 3rd cannot equal to 0. And simply again, because they're all being multiplied, a cannot equal 0 and b cannot equal to 0. And then simplifying, we have a 6 and a 3, so 6 and 3 both have a 3 in common, so that becomes a 2 and a 1. A up in the numerator, we have 1a in the numerator, that'll cancel out 1 down in your denominator, so we have 4 a's left down here. 1b will cancel out 1b down here, we still have b squared down in our denominator. So up in our numerator, we have everything cancel except our 2. In our denominator, we have an a to the 4th and a b squared. In our third examples, we'll use our factoring skills we talked about in example 1, and then we'll also be solving polynomials to find these excluded values. So first, to find our excluded values, take your denominator, x squared minus 16, and set it equal to 0. To solve, we'll have to factor. So think about, you have two terms and they're subtracted, and then what's special about 16? 16 is a perfect square, so we can factor it into two conjugates, x plus 4, x minus 4 cannot equal to 0. And then solve each of those for 0. X cannot equal 4 or negative 4. The second phase of this problem is to simplify. So we have our x plus 4 in our numerator. And in our denominator, we've already factored. That factors into x plus 4, x minus 4. Then we check to see, are there any common factors? There are. So x plus 4 simplifies with the x plus 4. Those will cancel each other out. And then we're left with 1 over x minus 4. Our last problem, we have an advanced trinomial in the denominator, so we'll start by finding our excluded value. So 2x squared minus 5x minus 12 cannot equal to 0. So we look to factor. So we know our factors will have to be two binomials because it is a trinomial. And to multiply to 2x squared, the only way to do that is with a 2 and a 1. And to multiply to 12, there's some options for that. You can multiply to 12 with a positive 3, negative 4. Then we can check our outsides would be 2 times -4, which is -8. Insides would be 1 times 3, which is +3, and that's going to add up to -5x. So our factors then are 2x plus 3, x minus 4. Each of those cannot equal 0, so we have a 2x plus 3 cannot equal 0, x minus 4 cannot equal 0, and that leaves us then with x cannot equal -3/2, x cannot equal 4. As far as simplifying this, we are going to make sure we factor both our numerator and denominator. Our denominator is already factored. We did that when we found our excluded values. We had 2x plus 3 times x minus 4. And then in our numerator, we have two terms with a subtraction. And then look at those numbers, 4 and 9. What's special about those? Yes, those are perfect squares. So our factors are conjugates, 2x plus 3 and 2x minus 3. Then we check again, are there any common factors? Yes, 2x plus 3, 2x plus 3. And we are left with then 2x minus 3 over x minus 4. Thank you. You are now ready to do the class check in Schoology. So there's a 5-question assignment that goes with this lesson. And remember, you can always go back, watch the video again. And the notes are also in Schoology if you want to print these out, or you can always just work these problems out on a separate sheet of paper. Thanks.